This is SpaceTime, Series 28, Episode 49, for broadcast of the 23rd of April, 2025. Coming up on SpaceTime, NASA's Lucy spacecraft takes a closer look at the asteroid Donald Johanson, the discovery of a new upper limit for the mass of the Neutrino, and intriguing Martian rocky outcrops discovered on the rim of Jezero Crater. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Lucy mission to explore Jupiter's Trojan asteroids is about to undertake a close flyby of the main belt asteroid Donald Johanson. Lucy is passing within 960 kilometers of the 3-kilometer wide space rock located between Mars and Jupiter. About 30 minutes before closest approach, Lucy will orient itself to track the asteroid, during which time its high-gain antenna will turn away from the Earth, suspending communication. Guided by its terminal tracking system, Lucy will autonomously rotate to keep Donald Johanson in view. As it does this, Lucy will carry out a complicated observing sequence. All three of its science instruments, the high-gain resolution grayscale imager called L-Lorry, the color imager and infrared spectrometer called L-Ralph, and the far-infrared spectrometer called LITES, will all carry out observation sequences very similar to that which will take place when it encounters the Trojan asteroids. One of the weird things about these deep space missions is that it teaches scientists just how slow the speed of light seems. Well, I guess it's all relative. Lucy will be some 12.5 light minutes away from the Earth during the close flyby, meaning it will take that long for the signals from Lucy to reach the Earth and another 12.5 minutes before a response from the Earth gets back to Lucy. This will be the second asteroid close encounter for Lucy and will serve as a dress rehearsal for the spacecraft's main targets, the never-before-explored Jovian Trojan asteroids. Back in November 2023, Lucy successfully observed the tiny main-belt asteroid Dinkinesh and its small contact binary moon Salem. A report in the Planetary Science Journal claims new modelling indicates that Donald Johanson may have formed about 150 million years ago, when a larger parent asteroid broke apart. When Lucy flies past the space rock, the data collected will provide additional independent insights into the asteroid's shape, surface geology, and cratering history. Lucy's deputy principal investigator, Simone Marchi from the Southwest Research Institute in Boulder, Colorado, says based on ground-based observations, Donald Johanson appears to be a peculiar object. And understanding the formation of this asteroid could help explain some of those peculiarities. Data indicates that it could be quite elongated and a slow rotator, possibly due to thermal torques which have slowed down its spin over time. It's a common type of asteroid, composed of silicate rocks and perhaps containing clays and organic matter. The new study also indicates that Donald Johanson is likely to be a member of the Aragon collisional asteroid family. That's a group of asteroids all on similar orbits that were created when a larger parent body broke apart. The family originated from the inner main asteroid belt, not very far from the source regions of the near-Earth asteroids Bennu and Ryugu. They were recently visited respectively by NASA's OSIRIS-REx and JAXA's Hayabusa 2 missions. As for the asteroid's name, Donald Johanson, well, it's the name of the paleontologist who discovered Lucy, a fossilized Australopithecus hominid skeleton found in Ethiopia in 1974, which, by the way, is how the Lucy mission got its name. Just as Lucy the fossil provided unique insights in the origins of humanity, Lucy the mission promises to revolutionize science's understanding of the origins of humanity's home world. Donald Johanson's also the only named asteroid yet to be visited, while its namesake is still living. The Lucy mission's principal investigator, Hal Levison, also from the Southwest Research Institute, says the mission plans to visit 11 asteroids during its 12-year tour. The Trojan asteroids are located in two swarms, one about 60 degrees ahead, the other 60 degrees behind the giant gas planet Jupiter. The asteroids are kept in these orbital positions, ahead of and behind Jupiter, thanks to the areas being gravitational wells, known as the Lagrange L4 and L5 positions. These Trojans are considered relics, effectively fossils of the planetary formation process. Therefore, they hold vital clues to deciphering the history of our solar system. Levison says encounters with main belt asteroids not only provide a close-up view of these bodies themselves, but also allow scientists to perform engineering tests on the spacecraft's navigation systems before the main event to study the Trojans. This report on the Lucy mission from NASA TV.
About 150 million years ago, Earth's most recent supercontinent was in the process of breaking up. Sauropods dominated the lush, slowly separating landmass that would become today's familiar continents. Meanwhile, in the asteroid belt, a breakup of a different sort was taking place. The large asteroid 163 Origone was pummeled in a collision, shedding debris to form a new family of asteroids. Fast forward to 3.2 million years ago, long after the fall of the dinosaurs, when an early hominin walked upright through an Ethiopian river valley. Now, a robotic explorer named for our most famous human ancestor is heading to a member of the Origone asteroid family, en route to the fossils of planetary formation.
Liftoff. Atlas V takes flight.
NASA's Lucy mission launched in October 2021 and flew past Earth in 2022 and 2024 for a pair of gravity assists. In early 2025, Lucy entered the main asteroid belt, on course for humanity's first encounter with 52246 Donald Johanson. The asteroid was named in honor of the paleoanthropologist who discovered the Lucy fossil in 1974, rewriting the textbooks on human origins. While asteroid Donald Johanson has never been seen up close, its brightness varies greatly as it rotates, suggesting an elongated shape. It is a member of the Origone family of asteroids, made from fragments of the collision that took place about 150 million years ago. Earth-based observations suggest that Donald Johanson is carbon-rich, has an average diameter of about 4 kilometers, and spins on its axis extremely slowly, giving it a 251-hour day. Lucy will approach Donald Johanson from the direction of the Sun, traveling 13.4 kilometers per second relative to the asteroid. As its target grows near, the spacecraft will slowly rotate, keeping the asteroid in view. Over the course of a few hours, Donald Johanson will transform from a point of light into a detailed world. Lucy's long-range reconnaissance imager will capture high-resolution pictures throughout the flyby, providing our best look yet at the asteroid. Just before closest approach, when Lucy is about 900 kilometers from its target, it will abruptly turn its instrument pointing platform away from the Sun to protect its sensitive electronics. Shortly after the flyby, Lucy will perform a pitchback maneuver, changing the direction of its rotation to turn its high-gain antenna toward Earth. 2 hours later, data from Lucy will deliver the first close-up views of Donald Johanson, a surviving remnant of the solar system's chaotic past. Following the flyby, Lucy will continue to pass through the main asteroid belt. In August 2027, it will reach Euripides, an asteroid more than 10 times larger than Donald Johanson and a member of the Jupiter Trojans. These primordial and primitive objects are trapped in Jupiter's orbit and are considered the fossils of planetary formation. Between 2027 and 2033, Lucy will make 5 separate encounters with Trojan asteroids and their moons. It will become the first spacecraft to explore this ancient population, asteroids more than 1,000 times older than our most famous human ancestor, formed at the dawn of the solar system, long before dinosaurs ruled the Earth.
This is SpaceTime. Still to come, discovery of a new upper limit for the massive neutrinos, and intriguing Martian rock outcrops discovered on the rim of Jezero Crater. All that and more still to come on SpaceTime. This episode of SpaceTime is brought to you by our official virtual private network partner, NordVPN, the one we trust and the one we use right here on this show. Whether you're tuning in from your favourite cafe, an airport lounge, or just your living room, one thing's clear, the internet isn't always as private as it seems or as it's supposed to be. In fact, every click, every login, every connection you make can leave you exposed if you're not protected. Whether you're browsing, streaming, shopping, or just checking email on public Wi-Fi, your information is vulnerable to snoops, to trackers, and of course, to hackers as well. And that's where NordVPN comes in. It's your first line of defense. It encrypts your internet connection, keeping your data safe and your online activities private, even on unsecured networks. It also lets you access content from around the world, bypassing regional restrictions. So no more geo-blocking. And also it helps avoid annoying bandwidth throttling. We use it every day here on SpaceTime, and it's not just about security, it's about peace of mind. And right now, SpaceTime listeners can get an exclusive deal. up to 74% off a NordVPN plan. Plus, you'll get 4 extra months for free on top of that. And of course, it all comes with a 30-day money-back guarantee, so you can try it out completely risk-free. Just go to nordvpn.com/spacetime. That's nordvpn.com/spacetime. NordVPN. We recommend it. A new study has discovered the mass of one of the most enigmatic particles in the universe, the neutrino. The results show that the neutrino's mass is less than 0.45 electron volts. In other words, less than a millionth the mass of an electron. The findings, reported in the journal Science, reduces the particle's known mass range by a factor of 2. It tightens the constraints on one of the universe's most elusive fundamental particles and pushes the boundaries of science beyond the standard model of particle physics, the cornerstone of science's understanding of the universe. Neutrinos are elemental subatomic particles. They're generated through radioactive decay in stars, in supernovae, in nuclear explosions, in particle accelerators, and in atomic reactors. The neutrino is so named because it's electrically neutral, and because its rest mass is so small, it was once thought to be zero. They are the most common form of matter in the universe, having almost no mass, incapable of being accelerated to almost the speed of light. Neutrinos come in 3 known types or flavors: electron neutrinos, muon neutrinos, and tau neutrinos, each with their own specific properties. Now, confusingly, the 3 flavors of neutrinos don't line up with the 3 suspected mass species. It seems that each of the 3 flavors is made up of a quantum mixture of the 3 mass species. So, for example, a particular tau neutrino has bits of all 3 mass species in it, and those different mass species seem to oscillate between the 3 flavors. For example, an electron neutrino produced in, say, a beta decay reaction could interact in a distant detector as a muon or tau neutrino. Now, although they don't have any electric charge, neutrinos do have their own corresponding antimatter counterparts, identified by their opposite chirality or handedness. Neutrinos interact with other matter only through gravity and the weak nuclear force. In fact, they're so weakly interactive that right now several trillion are passing through you every second, and you don't even notice them. Precisely measuring the neutrino mass is therefore essential for a complete understanding of the fundamental laws of physics. Now, the other key term in this research is the electron volt. That's a basic unit of particle energy, the amount of energy lost or gained by a single electron accelerating from rest through an electric potential difference of 1 volt in a vacuum. And thanks to Professor Albert Einstein's famous mass-energy equivalence equation, E equals mc squared, energy equals mass times the speed of light squared, it's also used as a unit of particle mass in physics and astronomy. The new findings by the Karlsruhe tritium neutrino experiment Catron utilizes the beta decay of tritium, an unstable hydrogen isotope, to assess neutrino mass. The energy distribution of the electrons resulting from the decay enables a direct kinematic determination of the neutrino's mass. Catron uses a 70-metre-long beamline equipped with an intense tritium source and a high-resolution spectrometer with a diameter of 10 metres. This allows extremely precise neutrino mass determinations. The latest findings indicate neutrinos are at least 1 million times lighter than electrons, which are the lightest electrically charged elementary particles. But explaining this enormous mass difference remains a fundamental challenge for theoretical particle physics. Starting next year, a new detector system, Tristan, will be installed. This upgrade to the experiment will allow scientists to search for a hypothetical sterile particle which interacts even more feebly than known neutrinos. In fact, with a mass expected to be in the kilo-electron volt range, a sterile neutrino is potentially a candidate for dark matter. This is SpaceTime. Still to come, intriguing Martian rocky outcrops discovered on the rim of Jezero Crater, and later in the Science report, it seems the weather really does now suddenly go from boiling to freezing a lot more than it used to. All that and more still to come on SpaceTime. NASA's Mars Perseverance rovers discovered a cornucopia full of intriguing rocky outcrops on the rim of Jezero Crater. Mission managers say the diversity of the rock types along the crater's edge are offering scientists a wide glimpse of Martian history. See, studying rocks, boulders and outcrops helps scientists understand the planet's evolution history and the potential for past or even present habitability. Since January, the rover's cored 5 rock samples on the crater rim, sealing samples from 3 of them in its sample tubes. It's also performed close-up analysis of 7 rocks and analysed another 83 from afar by zapping them with a laser and monitoring the spectral emissions of the vapour being released. In fact, this has been the mission's fastest science collection tempo since the six-wheeled mobile laboratory first landed on the red planet 4 years ago. Perseverance spent 3.5 months climbing the western wall of Jezero Crater, eventually reaching the rim on December the 12th last year. It's currently exploring a roughly 135-metre tall slope which the science team calls Witch Hazel Hill. The diversity of the rocks found there has gone far beyond expectations. Perseverance project scientist Katie Stack-Morgan from NASA's Jet Propulsion Laboratory in Pasadena, California, says that during previous science campaigns in Jezero, it would take several months to find a rock that was significantly different from the last rock sampled and scientifically unique enough for sampling. But up there on the rim, there are new and intriguing rocks everywhere the rover turns. That's because Jezero Crater's western rim contains tons of fragmented once molten rocks that were knocked out of their subterranean home billions of years ago by one or more meteor impacts, including possibly the one that produced Jezero Crater in the first place. Perseverance is finding these formerly underground boulders just to position with well-preserved layered rocks that were born billions of years ago on what would become the crater's rim. Perseverance collected its first crater rim rock sample, named Silver Mountain, back on January the 28th. NASA scientists informally named Martian features, including rocks and separate rock samples, in order to help keep track of them. The rock it came from, called Shallow Bay, most likely formed at least 3.9 billion years ago, during Mars's earliest geologic period known as the Neutrino, and it may have been broken up and then recrystallized during an ancient meteor impact. About 110 metres away from that sampling site is a rock outcrop that caught the science team's eye because it contains igneous minerals crystallised from magma from deep within the Martian crust. Igneous rocks can form deep underground from magma or from volcanic activity on the surface, and they're excellent record keepers. That's because the mineral crystals within them preserve details about the precise moment they were formed. But after 2 coring attempts in early February fizzled due to the rock being so crumbly, the rover drove about 160 metres northwest to another scientifically intriguing rock named Tablelands. Data from the rover's instruments indicate that Tablelands is made of almost entirely serpentine minerals. They were formed when large amounts of water reacted with iron and magnesium-bearing minerals in igneous rock. During this process, the rock's original structure is mineralogically changed, often causing it to expand and fracture. Byproducts of this process sometimes include hydrogen gas, which can lead to the generation of methane in the presence of carbon dioxide. And on Earth, these sorts of rocks are known to support microbial colonies. Coring Tablelands went smoothly, but selling it in the canister became an engineering challenge. Over 13 sols or Martian days, mission managers used a tool to brush out the top of the tube 33 times, making 8 sealing attempts. Finally, at the start of March, a combination of flicks and brushings cleaned the tube's top enough for Perseverance to seal and store the serpentine-laden rock sample. 8 days later, the rover had no issues sealing a third sample rock, this one called Main River. The alternating bright and dark bands of this rock were like nothing seen before by the science team. Following the collection of the Main River sample, the rovers continued exploring Witch Hazel Hill, analysing 3 more rocky outcrops, Sully's Grove, Dennis Pond, and Mount Pearl. This is SpaceTime. This episode of SpaceTime is brought to you by Incogni. Just because we're exploring the vastness of space doesn't mean there's not a lot happening here on Earth as well, especially when it comes to your personal data. See, every time you sign up for something online, every time you search for a product on the net, or even just browse the web, your data is being scooped up by companies called data brokers. Now, these are folks who collect, buy and sell your personal information, often without you ever knowing. And that's where Incogni comes in. It's a powerful hands-off service that helps you take back control by getting your data removed from the databases of those brokers. And they do all the legwork, sending out official removal requests, following up and making sure your information actually does get deleted. It's simple, it's effective, and it's a big step towards reclaiming your digital privacy. And right now, SpaceTime listeners can get an exclusive 55% off their Incogni subscription with a 30-day money-back guarantee. So just head over to incogni.com/spacetime. That's incogni.com/spacetime. Incogni. And time now to take another brief look at some of the other stories making news in science this week with a science report. Well, if you feel like the weather's suddenly going from boiling hot to freezing cold more than it used to, you may well be right. A new study reported in the journal Nature Communications shows that Australia is one of the regions in the world where rapid temperature flips from hot to cold or vice versa are occurring most frequently. Researchers found that these flips have increased in frequency, intensity and transition speed since 1961. In fact, the studies found that Australia has seen some of the largest increases in frequency of these temperature flips over the past 60 years. A new study claims that lab-grown chicken nuggets could be a reality in the near future. A report in the journal Trends in Biotechnology claims the prediction comes after researchers produced over 10 grams of cultured chicken muscle. The authors used a hollow fibre bioreactor which mimics the circulatory system to deliver nutrients and oxygen to artificial tissue. And a robot-assisted assembly system then produces bite-sized pieces of whole-cut chicken meat using chicken fibroblast cells which make up connective tissue. While researchers say they're still working to improve the taste and texture, the technology could one day provide a sustainable, ethical alternative to conventional meat, as well as a platform for regenerative medicine like growing organs and for soft robots. Psychologists are now warning about the potential dangers of having a relationship with your AI chatbot. In an opinion piece in the journal Trends in Cognitive Sciences, the authors say that because AI-human relationships can seem easier than human-human relationships, AIs could interfere with normal human social dynamics. But the authors are also concerned that AIs can offer harmful advice. They note at least 2 people are known to have killed themselves following AI chatbot advice. And while these suicides are an extreme example of this negative influence, the researchers say that these close human-AI relationships could open up people to manipulation, exploitation, and fraud. Tech giant Google has lost a major antitrust case in the United States. The US Justice Department, together with 17 American states, sued Google, arguing the tech giant was illegally dominating the technology which determines which adverts should be placed online and where. This is the second antitrust case Google has lost in a year after it ruled the company also had a monopoly on online search. With the details, we're joined by technology editor Alex Zaharov-Reutt from techadvice.life.
Well, a federal judge has ruled that Google has violated US antitrust laws, and he says that they've done that by willfully acquiring and maintaining monopoly power in the ad market. Now, the actual advertising business itself was not seen to be a monopoly, but the publisher-side ad tech did constitute illegal monopolization. Now, there's fines of potentially up to $100 million for corporations and $1 million for individuals. And look, a judgment is yet to be made on what's going to happen. It could see Google forced to divest some of its ad business. And really, Google is not a search engine. It's really an advertising business.
It's more than just the divestment. It could see the entire conglomerate broken up, couldn't it?
Well, anything is possible, and that would put into question how strong Google's AI systems will be, because I'm sure it relies upon lots of different information from all these different sources. One of the things we saw with Elon Musk is that his XAI business, which produces Grok and has 200,000 of those special NVIDIA chips in a massive computing system, it purchased the X platform for US $33 billion, and that gives Grok the ability to mine trillions of X posts for the most up-to-date information. So this battle is being fought across several fronts. And look, it is true that Google does have a massively strong position in advertising, and that's why the Sherman antitrust laws were put in place. Now, a judge has ruled that Google is in violation, and 2025 is going to be a very interesting year.
New update for iPhones?
Yeah, 18.4.1. It's also available for the iPads, and there's updates for your Macs and Apple TVs and other devices. But this particular one, besides the usual security bug fixes, it also fixes a problem where sometimes your iPhone is not connecting to your CarPlay. I haven't particularly seen that one myself, but that is definitely a reason to upgrade. And Apple is also saying that we should expect to see more Apple Intelligence features in the US fall, which is the Australian spring. So Apple's a little bit behind on its AI features, but it's trying obviously as hard as possible to catch up because this is the new reality.
That's Alex Zaharov-Reutt from techadvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.